The world has entered the age of preservation. We face massive challenges. Our planet's resources are dwindling, while our demand for them continues to rise. Existing infrastructure must withstand increasing pressures.
We can't continue as we've done.
Digging out more gravel or blowing out more mountains, use what's already there.
Reduce the usage of raw materials.
It's a necessary part of the future.
It is imperative that we focus on reusing materials that have already been used.
If it's possible to use, then you have to use it.
Recycling is the logical option.
It is part of the solution.
Being able to get up to 96% reuse of material instead of using virgin materials is incomparable.
When you go cold mix, it's the holy grail.
And it can be done.
It is being done.
Valuable raw materials must not be wasted. Recycling is not just an option, but a necessity. The condition of our infrastructure is no exception.
Political time frame and infrastructure time frame are different.
There's hardly any tenders. It's a shame.
We are still doing the same stuff, so what we change?
We need to think a bit out of the box.
First of all, there must be the political will to change that.
The European road network is nearing its breaking point. 1/3 of the roads exhibit major defects, and the investment backlog runs into the hundreds of billions. Even with conventional construction methods operating at full capacity, the situation will continue to worsen. The condition of the roads threatens to deteriorate exponentially. Alternative, sustainable, and effective solutions are needed. Methods that are already reliably relieving the burden elsewhere.
I don't know how widespread it is in Europe, but I know in the United States, we are coast to coast cold recycling. I would say at least half of the states have a pretty decent cold recycling department in which they are utilizing these applications to their benefit.
Among the various approaches to road rehabilitation, coal recycling is the most effective, sustainable, and environmentally friendly method without compromising quality or imposing restrictions on load classes.
Well, let's maybe start in another way. So the standard pavement we're building in Germany on the top layers is a pavement made of hot materials. So we're producing asphalt in a stationary mixing plant. We heat it up, and so cold recycling is a good way of producing some kind of bound pavement without heating everything up, so saving fuel, saving CO2.
The recycling is reusing existing road material. You're reusing it at the same level, which is really what recycling is. You're not downgrading.
Yeah, maximizing it.
I think that's the combining of the two. Reusing materials, reusing asphalt, reusing the base materials, and do it as a cold material. We have to go into the sustainable pavements, and then recycling is the logical option.
The whole objective is to bring in as less material as possible on the job site. And on top of that, you're gonna bring a minimal adjustment. It can be lime, it can be cement, but obviously you need to bring in some binder. So you have two main techniques. You have emulsion-based techniques, and you have bitumen foam technique.
When it comes to BSMs, to bitumen stabilized material, it's important to understand of what kind of material we are talking about. So it's a non-continuously bound material.
With bound materials, the focus is on strength, whereas with non-continuously bound base courses or materials, that is BSM, we have a certain degree of flexibility that allows for deformation to a certain extent without tearing, thanks to the microbonding within the material itself. You can imagine it as millions of tiny connection points linking the larger pieces, much like a skeleton.
So that's why it's not some kind of cold mixed asphalt. It behaves more like granular material. So this is important when it comes to the right design of the pavement with BSM.
To know more about it, we actually have to do an investigation of the materials.
The general process is quite uniform, but the actual mix design is very project specific. You need to understand what exists in the road, and then what you're bringing in for your structural layers.
That's the design.
Exactly.
The mix design is a suitability test for the existing or intended material to ensure it meets the requirements of the tender. For an accurate suitability test, a preliminary investigative site assessment is necessary. The suitability test is conducted on the collected material in the laboratory, using various tests according to guidelines. The results are used by civil engineers to calculate and design the structure in accordance with the requirements.
So having that flexibility with the mix design process lets you take a much wider variety of material to create a structural base layer.
Weather-wise, it can't be pouring down rain, but if it's normal rain, it don't matter, because we use actually water with the BSM. We use water to compact. So we just save on the compaction water if it rains.
We did cold mix projects in Sweden in the 90s, and we have plenty of examples in Sweden where we have roads that have 20 plus years. So we know that it will last if you're doing it properly. So you really need an engineered emulsion. We have the chemistry or we have the technique to adapt to the climate, but you're not gonna do it when it's minus 10 degrees. So you have a season, but it doesn't prevent you from doing it. It's planning. But whenever it's done and you allow those 2-3 weeks of cohesion build-up, your road's gonna last for what you planned it for. And it's a rapid way of constructing because you can open to the traffic, immediately.
BSM has a really good performance. At the end, we see that the bearing capacity of BSM is similar to bearing capacity of standard section made with asphalt.
There are two ways of doing cold recycling. The one way is that we use the old road, which is already there, so we mill it up. So we use everything which is there on the road already. The other way is that we bring in materials which are also recycling materials like RAP or other things which we have recycled on another site.
In-plant describes the stationary production process of cold mix using a mobile mixing plant. Ideally, this is done in close proximity to the construction site. In-plant is the method of choice when, for example, measures are required in the subbase, when using stockpiled material in new construction, in complex installation conditions, and in many other situations. For this, the excavated or stockpiled aggregate is used to produce cold mix and is installed on the construction site, preferably using a paver. This material gives us greater flexibility. When we have a large construction site and repeatedly face traffic congestion issues, where conventional mix gets stuck in traffic and simply arrives at the site too late, the critical temperatures are often too low, meaning that, in the worst-case scenario, the material can no longer be processed. BSM is a material that, when stored properly, can still be used days later, offering a decisive advantage over conventional construction methods. For construction material logistics, this means that we will be able to completely do without insulated lorries for the material in the future. Looking at it the other way around, it could also happen during installation that our machinery fails. Conversely, that would mean that if the mix is on the construction site, we cannot install it. We are making the process significantly more effective here with a bitumen stabilized material. During paving, it should be noted that air quality limits resulting from vapors and aerosols generated during the hot processing of bitumen are completely eliminated here. There is also potential for energy savings in the extraction of the material or in the manufacturing process. In cold recycling, the material is cold, meaning the energy savings are inherent to the material itself. It's important to note that when working with bitumen stabilized material, we're also able to complete our projects more quickly. And installing BSM material is significantly more cost-effective compared to a conventional asphalt-based course and asphalt binder course. In situ recycling with the CR production system represents a continuous rehabilitation process of the base course using the machine on site. The removal, mixing process and placement of the material are carried out in a single pass. Through pre-milling and pre-laying by a conventional road milling machine, the working width is highly flexible. The downcut process influences the material in terms of the required particle size distribution. We at Seismayer Straßenbau are rehabilitating a municipal connecting road here. The cracks have penetrated so deeply into the substructure that applying a new asphalt surface layer will no longer be effective. For this reason, the road would have to be completely excavated and essentially rebuilt from scratch. That would require a full road closure for about 6 to 8 weeks. We're realizing this project using the cold recycling process. The big advantage of this approach is that it's much faster than if we had to remove everything and start over from scratch. Furthermore, we're saving a lot of truck transport here, because all the material we need for our new improved base course is right here on site. Nothing is hauled away or brought in. It's processed here and immediately reinstalled on site. As a result, the road will have a longer durability than it ever had before. Construction time can be reduced by up to 40%, meaning full closure periods are reduced by 40%. Costs can be lowered by approximately 25%, and the environmental benefits are significant.
It all gives the same result. So we are producing a layer made of recycled material which is able to withstand the traffic. And this is the main aspect in my opinion. So we shouldn't focus too much on the small differences there are, but on the overall result of it. What do we want to build and what is it good for?
Numerous pilots and test sections using cold recycling have already been built in Europe, ranging from rural roads to highways. These, along with decades of experience worldwide, demonstrate that the cold recycling process for road repair is in no way inferior to traditional methods, but rather offers unique advantages for all challenges of future-oriented infrastructure maintenance.
First of all, environment, big plus, CO2, big plus, less trucks, big plus.
Transport. So that's a big one.
If you compare one-to-one how you would redo the road and actually get rid of the damage that are in the road, is way cheaper to recycle because you use what is already out there. Because one of the big impacts on cost is the material, is the raw material that you need to put in place. With the recycling, could do the whole thing in place and then just cover with the surface layer. So you save a lot of transport and you save a lot of materials.
The best potential for BSM is usage of reclaimed asphalt pavement. In our project we use 75% of reclaimed asphalt pavement and only 25% of native material. But it's possible to make it better. For example, if we perform the recycling in situ, we are able to recycle up to the 100% of all material, and this is the way we should do in the future.
Particularly in Europe, the aggregates and the materials are like gold, and you don't want to lose them.
There's a general trend which we see that things which are environmentally friendly getting more and more interesting to us, not only in terms of reducing money, but in terms of reducing the impact on the environment.
Without consistent support for innovative processes such as cold recycling, the future viability of our infrastructure cannot be guaranteed. Only through the systematic use of these technologies can we conserve resources and drastically reduce CO2 emissions.
We all together signed the Paris Agreement, and we do need to reduce the CO2 emission, and we do need to reduce the usage of raw materials. So be circular. Go from a linear economy to a circular economy.
The cold recycling in the future will be a really important topic because I'm coming from a construction company, and each construction company should set goals for the future. For example, Strabag should be up to the 2040 CO2 neutral. That means BSM can help us to achieve these goals at the end.
We at BAM have looked into how challenging it will be to meet our targets for 2030 and further on. It will be very challenging, and we've also seen that with a few BSM projects, we're making quite an impact on that. Specifically for the circularity, being able to get up to 96% reuse of material instead of using virgin materials is incomparable. So we believe that having BSM as a pavement option is a must-have to be able to reach those targets.
I've been doing some back calculation, and in average it has been about 60% CO2 savings compared to what you would have done with traditional asphalt in the given site.
But it's not only CO2. When we talk about CO2 only today, then we are wrong tomorrow. So we have to address all the environmental impacts, in my opinion. So like water use, land use, whatever there is. So there are a lot of categories, and we have to address them all at the same moment, because otherwise we optimize in the wrong way. Cold recycling is addressing most of these categories positively.
Every measure must be part of a holistic repair concept that meets technical specifications and takes ecological and economic aspects into account. Currently, however, there is a lack of clear requirements and funding for this construction method, which is reflected in a limited supply. Contracting authorities and expert circles must actively drive this paradigm shift forward.
The problem is, in Germany, we don't have the technical guidelines for BSM. That's why it's not being built, and that's why we don't have the experience on how the material behaves, if it's good, if it's sustainable. So in order to get these experiences, we can look at our neighbors where they have also similar climate conditions like in Germany and see what they have done in the last years when it comes to BSM and just learn from their experience. We don't need to reinvent the wheel when it comes to this topic.
So, together with the Flemish Road Agency, we described standards and guidelines for the Flemish industry. That means that when they use the guidelines, they are allowed to use BSM now as an alternative for unbound and bound base layers. And the question that why it is put so fast in our standards, but it's just all a matter of collaboration between industrial partners and authorities and the research group, of course.
In terms of art, it might be having to broaden the view on the participants of the art seminar. We should also have the municipalities and the politicians that actually is going to be demanding the products to be used. So maybe we should get more of those in here.
Events like the art are extremely important to spread that knowledge, which is there all over the world. We have to talk about the other advantages, not only the technical ones, but here we have some specific advantages in terms of environmental impacts, and we have to put that more to the front and talk about that to influence the political will or to make the politicians see the need for it.
I hope if we are not doing on our own to push cold recycling, European Union will push us to do more of it. So, for example, in my country, last couple of years, we are trying to push the cold recycling technologies in our road reconstruction, but still we are not using not even 30% of what is possible to do. We will have to do it, but I hope that we will accept that not because we are forced to accept, but to see the benefit of it.
At least enhance that it has to be used. If it's possible to use, then you have to use it, instead of rethinking old ways and just digging out more gravel or blowing out more mountains. So use what's already there.
We can't continue as we've done.
Yeah.
It's a necessary part of the future.
And we definitely need it. Otherwise, our roads are going to become even worse.
And roads are access to your economy.
The first step is to have the political will to change that, and then we can adapt the technical regulations according to that political will.
I hope that we stop doing this in Germany and then doing this in Lithuania and then doing this in the Netherlands, and we do it all apart from each other. I think it's good to combine our efforts, combine our engineering capacity, and then make new normatives and use all the knowledge together.
And we need to create an ecosystem where every stakeholder has really an important task within this chain of asphalt recycling train. So actually the question is, why don't we do that?